Hello everyone, I'm Shubhashish Raditya from the University of Maryland, Baltimore County. Today I'll be presenting our work titled QT Query to Event Decomposition for Zero-Shot Multilingual Text-to-Video Retrieval. It was conducted in collaboration with my advisor, Dr. Frank Ferrer. Video retrieval is a solved problem if you have perfect metadata, but retrieving videos is incredibly hard when that metadata is missing. The central question of our research is, how can we improve retrieval in these zero-shot scenarios? Can we do it by enriching the query, or perhaps by leveraging hidden information within the video itself? We can approach this improvement in two ways. First, by enriching the user's query, and second, by extracting better information from within the video itself. Let's look at the query side first. We enrich the query by decomposing it into multiple relevant events. For a given user query, 2025 LFR, the issue is how can we get the specific video? Because 2025 LFR looks like any other fire. To give more event-specific information, we ask three questions. First, we ask, what are all the events that happen during the given query event? Next, we ask, what might have led to this event? This gives us causal context. And finally, we ask what will happen next. By understanding the aftermath, we gain a full temporal understanding of the query. We call this using event schematic knowledge, leveraging the prior knowledge embedded in large language models. Now let's look at an example. Let's say the user queries for 2025 LFR. We ask the LLM what could happen during this event. We get back from LLM that one of the relevant events might be building on fire. This gives us concrete visual cues to look for. Next, we ask what could lead to this event. And the LLM gets back with dry lightning as one of the prequels that might lead to the fire. Finally, we ask what could be an outcome of this event. And we get back people are returning as sequel event. So now, instead of a single vague query 2025 LFR, we have a rich three-stage temporal narrative. Prequels as dry lightning, current as building on fire, sequel as people are returning. So going to the concrete framework, given the user query, we first decompose it into multiple prequel, sequel, and current events using LLM's prior knowledge. Next, we extract temporal, spatial, and category of the event from the query itself. We found that raw decomposition is not always enough. We add a refinement step. We take the decomposed events and the extracted entities and ask the LLM to rewrite them into natural, search-friendly descriptions. This gives us our final prequel, current, and sequel queries. Now that we have enriched the query, we must address the video side. How can we improve representation via information within the video? Video contains visual data, like trees and buildings are on fire. It also contains audio data. An AACL transcript might say, today, August 16, 2020, a massive wildfire has started. Note that the date in the audio 2020, our query is for 2025. This audio cue is critical for filtering out the non-relevant video, even though the visuals match. You might ask, can't vision language models just handle this? Not quite. Kind VLMs often fail to understand the full context or the bigger picture. Standard ASR fails to handle multilingual translation and transcription simultaneously and effectively. Here is our approach to the visual data. We don't just caption one frame. We sample 16 frames uniformly from the video. We pass this through a frame captioner to get a sequence of descriptions. We also process the audio. We extract the ASR module output. To get a holistic view of the video, we take those 16 frame captions and feed them into an LLM to summarize them into a single cohesive video caption. This connects the isolated frames into a narrative. We also provide the ASR transcripts to have more context from the audio cues. Now about the ASR module. We found that only using one ASR model, the outputs can be noisy due to the poor quality of the social videos and for the multilingual aspect. So we used a three-stage pipeline. First, we used the multilingual whisper model to extract the transcript in original language and one translated one. Next, we use an LLM translator to translate the original language transcript. Next, we use both of the translations to get a refined transcript using a LLM. Finally, we have both the enriched query and video. Now we have to calculate the similarity. We compare our decomposed query parts against our decomposed video parts. From the decomposed video, we have video caption, 16 frame captions, and audio transcript. From the decomposed query parts, we have the prequel, current, and sequel queries. For every video, we now have a matrix of similarity scores. We have prequel, current, and sequel scores against video captions, frame captions, and audio transcripts. The challenge is, how do we combine these? We are in a zero-shot setting, so we have no training data to learn weights. Using an LLM to rank them is computationally expensive and difficult because of the tokenization of the numbers or scores. Our solution is inverse entropy-based fusion. We convert the similarity scores into probability distribution. We calculate the entropy of these distributions. If a specific component, like the audio to sequel match, is very confident, it will have low entropy. We weight the score higher. This allows the model to dynamically trust the most confident signal, whether it comes from the audio, the visuals, or a specific event decomposition. Now the fun and most important part, results. We evaluated on multi-band. This is a challenging dataset containing over 2,000 videos across 5 languages. It focuses on complex events like earthquake or floods, not just generic actions or videos. First, we compare against multiclip, the model which was shown in the multi-band paper. It achieves an NDCJ of 75.34. When we apply our QTE framework on top of multiclip, we jump to an NDCJ of 83.24. This is an improvement of roughly 8 points. Next, we take the SOTA video retrieval model of that time, intern video 2. We see that it does poorly on the multi-event dataset. It was supposed to be as for the complex nature of the event videos. But applying QT and QT to intern video jumps the performance to 76.10. This proves that our decomposition method is model agnostic. It improves performance regardless of the underlying visual encoder. We conducted an extensive ablation studies to understand why it works. For the sake of time, we have shown some important ones here and provided all in the paper. Comparing fusion algorithms, mean aggregation gives us 82.44, whereas inverse entropy fusion gives us 83.24. It provides the best reweighting mechanism for the zero-shot multimodal task. We have also tried with simple ones like maximum aggregation, mean aggregation, to the more complex ones, but inverse entropy beats them all. Here is the breakdown by language and category. On the left side, we can see the language breakdown, where we can see that we gain consistent improvement across all the languages. On the right chart, it was aggregated by the categories of the video. We also see consistent gains across all the event categories like disasters, political, social, and technology. Finally, to see which part matters most in our framework, our full model set 83.24 NDCG. Removing query similarity drops it slightly, but removing video description causes a massive drop. It proves that visuals are the keys. Obviously, for the video retrieval, removing event decomposition drops it to 81.75. This confirms that QT extract complementary information. Every part contributes to the final score. In conclusion, we introduced QT, a novel framework based on decomposition. We demonstrated that LLM's parametric knowledge can enrich vague human queries with temporal context like prequel or sequel. We showed that combining VLM and ASR signals via inverse entropy fusion provides a significantly better representation of video. Our code and data are available via the QR code or the project page. Thank you for your time.